Hi, I'm Michael Lin, and I, along with Alex Gyoko, Lee Davis, and Zayd Mantar, are Team Phonics. So we all know that early childhood education is important, but the quality of education might not be uniformly distributed. For example, 34% of fourth graders in the U.S. still fall below basic reading levels versus 4 to 6% with intervention. And so we thought to ourselves, how do we be able to leverage the technologies we have now in order to apply this to better education? And one thing that we actually learned is that the way you pronounce a sound is actually really intrinsically tied to the way how well you can learn to read. And so this is called phonics actually. And so we decided to apply machine learning based inspired by recommendation systems to build a system that would help to teach kids to learn phonics. And part of the motivation was also that this is not easy to teach. Most parents don't have time to plan a full curriculum. For example, the average parent has 32 minutes of free time per day, and this can be exacerbated, for example, if the parent can't afford early schooling either. So we really wanted to be able to lower the accessibility barrier a lot, so that way all children can have a high quality education.
So we came up with a solution that we call Phonics. It's a mobile app that you can open and give to your toddler, roughly 3 to 5 years old, and it will start suggesting words to them. So for example, love here. The child will see the word. If they can't read it, they can click on the word and hear an example pronunciation of it, and then they can click on the microphone, give their own best take at trying to pronounce the word, and then our AI algorithms will analyze their speech and then check how good the pronunciation was. Then after we've gotten this data for a ton of words, we'll be able to analyze which words they were good and bad at pronouncing and then map those to their phonemes and see which phonemes children struggle with. Now that we know which ones they struggle with, we can recommend those words more and give them more practical experience rather than just feeding them words they already know how to pronounce over and over again. In addition, we'll have a statistics screen so that you can look and see exactly what sounds your child is struggling with.
So the way our technology stack works is that we first cluster common elementary school words by phenome. We cluster each. We have a graph that basically expands from the phenome that contains each of the words that contain that phenome. We then use Whisper to take a child's pronunciation as an audio input and use that to assess their level of fluency. And if we think that the child is struggling to pronounce the word in certain words, we'll then suggest words that have similar phonemes and then present it and then put it as part of our curriculum. So that way they can strengthen those areas of practice. And then we repeat this process until mastery is achieved over most of the fundamental basic phonemes.
So for our architecture, we decided to use React for the front end so that we can have this offered over any iOS or Android devices. For the backend, we use Flask to coordinate with the React.js and our Python to interact with the machine learning frameworks. For our phonics graph, we downloaded Merriam-Webster's dictionary for toddlers. That includes all these words along with their phonemes so that we can analyze the correct phonemes and which ones that the child is struggling with. We use Whisper AI to analyze the speech that the children give to our app and then identify which phonemes and how good they pronounce the word. And then we also have an audio database of all of the words in our dictionary so that children can hear examples of these words pronounced so they don't have to read them out loud and just guess.
This is live demo for phonics. As you can see, this is the mobile screen that shows the exercise for the student. They are prompted to pronounce the word down. If they click on the word or tap on it, the word will be pronounced out loud as it's spelled in the vocabulary. And then the child needs to repeat this word by pressing the microphone. Down.
Down.
As you can see, I pronounced successfully, and I got confetti, and the next word.
Off.
Next word is off. Off.
Off.
Yay, confetti. Now, let's pronounce this word incorrectly. Stoop.
Stoop.
As you can see, it didn't register as a correct pronunciation and prompts me to do it again. Stop.
Stop.
Yay, this worked. Thank you very much.